Hey there, and welcome. Have you ever stopped to think about how much history is just hiding inside a single day on the calendar? Well, today we're doing just that. We've picked a date totally at random, January 29th, and we're going to use it to unlock this incredible story of genius, discovery, and the human drive to just figure things out.
So really, what can one day tell us? Turns out, a lot. You'll see that January 29th is going to act like a sort of time machine for us, connecting these brilliant minds across hundreds of years. It's the lens we're using today to find this hidden thread that ties together some really fascinating people in the world of mathematics.
And look at this range. Our story today is going to stretch over 300 years. We're connecting a French priest who died way back in 1715 to a German number theorist born in 1810 to an American computer scientist from 1928 and all the way to Nigeria's first female professor of mathematics born in 1951. And what do they all have in common? This one day, January 29th.
Okay, so our journey starts with a bit of a twist. It begins not with a birth, but with a death. And with it comes this really powerful idea that's going to be the theme for our entire explainer today, the search for absolute clarity.
This right here is Bernard Lamy. He was a French mathematician who passed away on this day in 1715. And his words, wow, they're basically our guide for this whole journey. The idea that clarity is like a torch that just cuts through all the murky darkness, that's the goal.
I mean, this guy literally wrote the book on how to be a great explainer. It was called On the Art of Speaking. He argued that the real beauty in any idea comes from being perfectly, totally clear. He was so committed to this new logical way of thinking that he was actually exiled for it, just for supporting the philosophy of Descartes.
So, Lamy gives us our theme, clarity. But, what happens when the very language you're using, the language of math itself, starts to get fuzzy and, break down? How are you supposed to create clarity then?
And that question leads us straight to Eduard Kummer, another one of our January 29th minds. He was a German mathematician, and his work is the perfect example of someone having to forge brand new tools just to bring some light into a really chaotic mathematical world.
Right, so we all learn in school that any number has its own unique set of prime building blocks, right? Like the number 12 is always 2 times 2 times 3. It can't be anything else. But Kummer was working with these more complex number systems where all of a sudden that fundamental rule just stopped working. Can you imagine? It was like the rules of grammar just vanished. This was a massive problem, and it was holding up progress on huge challenges like Fermat's last theorem.
So what did Kummer do? He didn't just find some little fix, no. He invented an entirely new concept. He created something he called ideal numbers. It was like inventing a new language, a new tool that basically forced those unique building blocks back into place. This was a huge leap, a move that not only restored order, but really paved the way for modern abstract algebra. It's a perfect example of Lamy's torch in action. Okay, buckle up, because now we're going to jump way forward into the 20th century. The tools are different. We're talking computers and networks now. But that same basic search for clarity, for the simplest, most beautiful solution, is still what's driving everything. And here's Joseph Kruskal, an American mathematician born on this day in 1928. Now, if Kummer brought clarity to abstract numbers, Kruskal brought it to something we see every day, networks. Think about the internet, power grids, delivery routes, anything with points that need to be connected. The big question is, how do you connect everything using the shortest possible path?
And his solution, Kruskal's algorithm, it's so elegant in how simple it is. Instead of getting tangled up in all the possibilities, you just follow one simple rule over and over. Always pick the shortest available line that doesn't make a closed circle. You just keep doing that. That's it. And by repeating that simple step, it beautifully guarantees you find the most efficient network. It's the perfect torch for a really complicated problem.
Our last key figure, born on January 29, 1951, she shows us that this quest for clarity isn't always about abstract problems. Sometimes it's a very personal fight for your own place in the world of ideas. And this is Olabisi Ugbebor, an absolute trailblazer.
Just try to imagine this. You walk into your university math class, and you're the only woman there. And the men in the room openly challenge your right to even be in the same room. Well, Olabisi Ugbebor didn't back down for a second. She met that prejudice with her own powerful clarity of purpose and just flat out refused to be intimidated. That's a whole other kind of strength.
And now listen to her teaching philosophy, because this brings us right back to where we started with Bernard Lamy. I don't lecture, I teach. She makes her classroom a safe space where no question is dumb, because she knows if a student is scared to ask for help, their path to understanding is totally blocked. She is literally using her classroom to dispel obscurity and make things visible for her students. It's beautiful.
So the 4 people we've met are just incredible, right? But believe it or not, they are just a few of the threads woven into this amazing intellectual tapestry of January 29th. I mean, the sheer amount of discovery tied to this one day it's just astounding.
For instance, also born on this day was Sidney Chapman. Before him, the upper atmosphere was pretty much a complete mystery. He was the one who brought clarity by figuring out the first real theory of the ionosphere, which explained how global radio even worked.
Then you've got William Ferrel. He was a meteorologist who looked at the totally chaotic patterns of global winds and was one of the first to develop solid theories to explain them. He brought a new kind of clarity to a system that affects every single one of us.
And how about Gregory? He didn't just teach math, he helped build a lasting home for discovery. He was a co-founder of the Royal Astronomical Society, an entire institution designed to bring clarity to how we understand the stars.
So, what have we really seen here? On one random day, we found this amazing story that crosses centuries and cultures. From a French priest to a Nigerian professor, they were all connected by this single goal: to take something messy and complicated and make it clear. And that is the real story of mathematics. It's not just formulas, it's a relentless, continuous human quest.
And that kind of leaves us with a final thought. We've spent our time looking at the history made on January 29th in the past. But somewhere out there, right now, is the next Kummer, or the next Kruskal, or the next Ugbebor. What new kind of clarity are they fighting to create, and what mathematical history is being written today?